I'm Dr. Mahammad Rafi, Associate Professor, Department of Cybersecurity at Institute of Aeronautical Engineering. Today I want to discuss about computer network subject, in which the topic is network layer. The outcomes of the network layer is low latency communication. Low latency the communication means now timely delivering the data. That means from source to other destination. Here is with minimizing delay, with a minimum delay, timely, which is other delivering the data. It is called as a low latency communication. Low latency communication can be achieved in a real-time applications like voice over the internet protocols or other videos, other conference. And reliable data delivery. Reliable data delivery means now guaranteed data will be delivered to the destination, guaranteed accurately, and timely data transmissions can be done like autonomous other vehicles and industrial control system. So these are all the reliable data delivery can be achieved. Here is next the outcome of the network layer is quality of service can be provided. Generally, data traffics, the quality of service can be provided. If the data over the networks, over the large number of other networks, the traffic is a heavy traffics. In this heavy traffics now, the quality of service can be provided with help of the network layer. And also now the performance for the high prioritized applications. So, such as in online gaming and the financial other trading now, providing the quality of other services by using the with help of the network layer. These are all the outcomes of the network layer. Low latency communication, reliable data delivery, and quality of services are the outcomes of network layer. Introduction to network layer. Here is network layer. Generally, it is a very critical layer in a OSI TCP reference model. Generally, here this layer can be utilized in a OSI reference model and TCP/IP reference model. The TCP/IP model, that is transmission control protocol and internet other protocol model. This network layer can be used. Here is now this network layer in this TCP OSI reference model and TCP model. This network layer providing the other communication. Here is now which is enabling and providing the other communication between the different devices across the large number of networks. Generally, this network layer which is working as a bridge between the lower layers and higher layers, which is acting as a bridge between the lower layer and higher layer. That means by acting as a lower layers generally here, which is physical data transfers, concerning with the physical data transfers. Higher layer will be focused on the application specific other communications. In between this lower and the higher layer, which is acting as a bridge and supporting for data transmissions from lower layer to the higher layer. Generally, these network layers now, which is providing to end-to-end communication. That means end-to-end communication or point-to-point communication or device-to-device or node-to-node communication can be provided by using the network layer. So, these are the communication can be managed with help of the logical address. Logical address now generally can be generated while executing the program. While executing the process, generally this logical address can be generated. And routing, by routing now, which will provide the end-to-end communication and routing also. And forwarding of a data packets. Once if you forward the data packets now, so these this can be provided. Here OSI model. So this is a structure of the OSI model and a TCP IP model. So in OSI and TCP IP model now, OSI model if you take now, which is having the 7 layers and which is having the TCP IP model having the 4 layers, both in OSI model and TCP IP model now we are using the network layer. This network layer now which is acting as a bridge between the transport layer and the data link layer. Here also now which is TCP IP model now which is acting as a bridge between the transport layer and network access layer. That means now what it is doing by acting as a bridge means now generally the transport layer now which is transferring the data in the form of the tokens. So these the tokens can be converted. So with help of this network layer now, this network layer now which is encoding the tokens. Whatever the tokens are transferring by this is the transport layer. The tokens can be converted as the packets, data packets. So these the data packets can be that is again decode here. So again here decoded into the data frames. From that the data frames now, so it will be decoded as a raw data, that is a 101010 binary form. So why? Because now the physical layer now which is the transferring the binary form. The mission can be understand only the binary form, binary data. So that's why this network layer now which is supporting and converting the upper layer data to the lower layer understandable other form. So by converting it here now it will be the transfer to the destination device. So this is the network layer, the locality in a diagram. Here some of the functions of the network layer. Functions of the network layer here, you see the functions of the network layer are assigning the logical address, routing and the forwarding and path determination, logical subnetting and fragmentation, resembling. Here enter the connectivity, encapsulation and decapsulation, congestion the control, network address the translations and the quality of the services, error handling. So these are all the functions of the network the layer. With help of this the network layer now, so all the functionalities can be performed for the large area networks. Here is one by one now. Let us discuss one by one. First, assigning logical address. So this is the function of the network layer. So this assigning logical address function now, with help of this other function, assigning the logical address, that is the IP address. When it is generating the logical address means while executing the program, while processing, this logical address will be generated. So once if the logical IP address is generated now, it will be assigned to the unique identified device, That means now whatever the device is identified over the network now, that will be assigned. Once if it is assigned to the device, unique the device here, now which is ensuring the data packets are sent or received by the intended the parties. That means here using the host ID and network ID, using the host ID and network ID. So the data packets can be received or sending the data packets. That means here now, here is logical address. This logical address now it will be generated while executing the program. Here the one after generating this the logical address now it will be assigned to the the physical address. Why? Because logical address with the help of this the logical address the transparency, we can't do the data packets transparency from one device to the another network. That means now one network to the another network now, or one device to the another device now, we can't able to send the logical address with help of this logical address. That's why now we are first this logical address can be converted into the physical address. By converting the physical address only, the data packets can be delivered. That means the data packets can be sent or data packets can be received by the destinations or by the intended parties. Here, how the data packets are delivering or how the data packets are receiving means here with help of the host ID or network ID. With help of this host ID and network ID, now with these identifications, now packet at the delivery and packet receiving can be done over the network. So this is a large area network. In this large area networks, the devices can be identified with the host ID and network ID. That host now working in which network, that can be identified. And the routing means now generally source to destination. In between the source to destination, number of routers will be arranged generally in a communication system. So among these are the number of routers. Now with help of this the routing the technology, we can find the best path. By finding the best path, now the data can be transferred. That means now the routing. So this the routing now what it is doing now, which is determining the best path. So here is the best path means now shortest distance. If it is find the best path or shortest distance from the source to destination, then the data packets can be delivered. Why? Because now in a network layer, data can be transferred in the form of the packets. So that's why here, after finding the best path, data packets can be transferred from source to destination. The destination should be identified. Source to the destination. For transferring the data packets from source to destination, here is over the network now, utilizing the routing algorithm. Best routing algorithms can be we can utilize, and along with the routing algorithm, the protocols also we can utilize the protocols and routing algorithm. Protocol, why we are using the protocol means now protocol is nothing but it can frame with a set of rules and regulations. Based on these rules and regulations, now these are the protocol now carrying the information from source node to the destination node. Here is the best number of the routers. This is the router 1. Number of routers will be arranged in between the source and destination. Here the destination node for the packet 2 and the destination the node for the packet 1, packet 2. Number of the packets can be transferred here. Here from this the number of the routers, the packet 1 can be transferred here, packet 1, packet 2 can be transferred to the destination. So while transferring these the packets, now the best path can be found. Best the path. Number of the routers will be arranged between the source and destination. From that now best path can be found. For finding this the best path, now we are using the routing algorithms and protocols. With help of these routing algorithms and protocols, now we can find and carrying the information between the source and destination. So that the best the protocols generally here in a routing, we are using the routing information protocol, that is RIP. So these routing information are the protocol now which is giving the best routing, which is giving the information about the best route, which is giving the information about the shortest route among the whatever the paths are available. From that the path here, this RIP of the protocol now shortest path can be found with help of this the protocol. And OSPF of the protocol, that means open shortest path first. Here OSPF protocol now which is finding the shortest path, which is finding the best path. From among the number of the best path, minimum distance the path can be opened and transmitting the data packets. And the border gateway protocol, here also BGP protocol also can be used. Border gateway the protocols here. By using these the protocols and routing algorithms, now determining the best path, and after determining the best path, data packets can be delivered. Here the data packets can be delivered from source to the destination node or end to end host the protocols. Actually now which is ensures the scalability and the efficient the data delivery. So across the large or complex networks, delivery across the large networks or the complex networks. And see forwarding Forwarding means now that is host to host delivery. That means one device to another other device delivery is known as a forwarding. So you see, it is the process. The forwarding is the process in which the network layer generally which is transmitting or forwarding the data packets, delivering the data packets via the number of other routers, after determining the best path or best router. Here always now the packets can be delivered. Always now the packets can be delivered after finding the best path. Here from the host A to host B, number of the paths are exist. Number of routers will be so the connected here, and networks number of in between this host 1 and host A, host B, here number of networks can be arranged. From the number of other networks now best the path. Here this network to network now two networks can be connected with help of the routers. With help of these routers now, that will be determined here via the routers. After via the routers, and it will be the forwarded. Now the packets now here. This is the IP address of the host A, and this is the IP address of the host B, and the routers here forwarding 0 by 0 the R1 router, and the forwarding here is a FA 0 1, and R1 routing the table now which is having this network address 192. So this is a one network address, and this one is another network address. Network to network the connectivity. So these are the host B is working in this network 10.0.0.0 by 8, and this host A is working in network address 192.168.5.0 by 24. So in this now these are working, and with help of this the routers now data can be delivered from one device to another device. Generally, next logical subnetting. Next functionality is a logical subnetting. The meaning of the subnet means the part of the network. That means large network now that will be divided into the number of subnet. So which is called as a logical subnet. That is the number of the chunks, smaller chunks. Also we can call it as a logical subnet. That's why the network layer generally which is allowing the bigger networks, large networks can be allowed. That will be divided into the smaller chunks or smaller networks based on the IP address of the whatever the network now we are utilizing. So this larger network is divided as a smaller networks is known as a logical subnetting. So this logical subnetting now is very helpful to managing the large networks. Large networks now it is subdividing the smaller subnetworks. Why? Because here the task by subdividing the smaller network now the task can be achieved very efficiently and very effectively. Efficiently we can achieve the task. Due to the smaller networks now easily finding the devices. Why? Because now each and every network having its one address, network address. By with help of this network address and host network ID and host ID, that the particular the subnet can be easily identified, and work also efficiently can be achieved. That means the reliability can be improved. That's why it would be very easily we can find the devices if any troubleshooting is required in a logical subnetting. That's why the subnetting now, these are all the internet. Internet is a large area network, interconnection of the network. In the server, it will be, the internet will be connected to the server. Over this, the internet now, the bulk amount of the data can be transferred. This internet can be divided into the number of subnet. So this is one subnet. So this is the IP address of the subnet 1. So this is the another other subnet. Now number of one network will be divided into the number of subnet, and data transmissions can be done to the all other subnet. So these are the subnets can be identified with help of the host IP address. That means host ID. That IP address now we can call it as a ID. Host IP and host IP address or network IP address. That is host ID. We can say it as a network ID. We can identifying the other devices. And fragmentation and reassembling. Fragmentation. So generally problems. Now these are the fragmentations and reassembling means each computer or each node or each device which is having the maximum transmission units, data transmission units, maximum number of the data transmission units. That means here which is having the data size, this maximum transmission unit based on this MTU, that is the maximum transmission units. Now the maximum data size it can be received, and if the data packets are exceed this limit now, which is exceeding means now that is the fragmentations. Data size whatever the MTU, based on that the MTU data packets are available, then no problem. Suppose the data packets, that means maximizing the data sites are maximizing the data packets so than the MTU, then the fragmentation can be arised more than the size of the MTU. If the data packets are available, then the fragmentation can be available here. That in that other case now what we are doing now, reassembling can be done. Here is the routers are the fragment into the smaller other packets. Now here in these other cases now the packet can be divided into the smaller packets. Whatever the other size is available, the MTU size here, based on the availability of the MTU size now the data packets, the suitable data packets can be divided as smaller packets, which are again now reassembled in order to at the receiver end. At the receiver end here again it is reassembled. Once why? Because now the data transmission, this maximum data transmission MTU depends upon the MTU, the size of the MTU. Based on the availability of the MTU, the packets can be divided, and after dividing these the packets into based on the size here, the data transparency can be done. At the receiver side again it is reassembled as a original size of the other data. So this is a fragmentation and reassembly. When it is coming here, the data size is more than the maximum MTU. This is the fragmentation situation will be arise. So that is a maximum transmission unit size, and reassembling can be done. By reassembling here the data can be transferred. Here is the error handling. Generally error can be arise in many situations now while communicating the data between the two devices. Here the network layer which is detecting and handling the errors by using the CRC and checksum techniques. Here is cyclic redundancy check or checksum other techniques. Now errors can be detected and correcting the errors by using the error correction method. By correcting the methods now, reliable packets or reliable data can be transferred. That means now reliable means here correct data. Correct data, whatever the data, the destination is the required here, that the correct data can be transferred by correcting the errors to the identified the destination device. That means the packet delivery can be done through the transmissions. And here is the once the packets can be delivered, so get the acknowledgement from the other device. Suppose if it is the packet not received, packet is not received by the destination, immediately the destination which is giving the negative acknowledgement, positive acknowledgement and negative acknowledgement. When we are getting the positive acknowledgement, whenever the data packets are received by the destination, then the destination now which is responded the positive acknowledgement. Whenever the destination receives the negative acknowledgement, now which is receiving the whenever it is responded to the negative acknowledgement, that means the destination is not received the data packets. So which is sending as a positive negative the feedback to the source device. Here is generally while communicating two devices, generally the two types of errors. Two types of errors can be arise. Two types of errors can be happened here. What are the two types of errors means now? One is a single bit error, another one is a burst error. Single bit error means here now only while transmitting the data in the form of the bits from source to destination, only one bit, the error is occurred in only one bit. That is a single bit error. Suppose now if you are going to transferring the data 1 1 0 1 0 0 1 here, the destination which receives, that means the bit error will be arised instead of 1 here. The destination mission now it is received as 1 1 0 0 0 0 1. So that means instead of 1 now which is receives the 0. Instead of 1 1 0 1 0 0 1, the destination mission receives the 1 1 0 0 0 0 1. So one bit, this is the error is occurred in only one bit. Burst error means now more than one bits. Suppose here if you are going to sending the data from source 1 1 1 0 1 1, here the destination can be receives the data 1 0 0 and 0 1 0. That means here instead of the 1 1, now the destination mission now which is receiving the data as a 0 0, and instead of the 1 now the destination machine receiving the bit as a 0. That means more than one different bits can be received by the destination. Whatever the sender is sending the message or in the form of the bits, so the destination receives the more than the two different bits. This is the, so these are the situation now we can call it as a burst error. So all these are the errors can be detected and handled by using the different error detection the techniques like CRC, the checksum, and once if it is detected, that can be the correction by using the different error correction that will be corrected and received by the destination as a whatever the sender sent, that original message can be received by the destination. Here, quality of service. Next, the functionality of the network layer is a quality of service. Quality of service means now correct data. Here, the sender sending the correct data with help of the network layer, which is delivering the exact data, correct data to the other destination. Timely delivery of the important data, correct data, right time it will be delivered. So this is the quality of the service. So by the prioritizing the traffic based on a quality of service, that means while in a large network generally the traffic will be arised. To overcoming this other traffic, the quality of the data can be transferred to minimizing the delays for the critical data types. Here is now network address translations. Next, the functionality is a NAT. Network address translation, generally this can be done with help of the network layer. Here, this is the network layer. What it is doing now, network address translation. Here is take care of these are the translations. That means now it convert any private IP address. Generally, the main, these are the functionality, the operation here, what operation we are performing means the private IP address. The private IP address into the public IP address. Here main network address translation, NAT can be translated the one IP address format to the another IP address other format. That is a private IP address to the public IP address conversion can be done by using the network address other translations. So here that means it is convert any private IP address into the a public IP address. And here which is required to communicating and to establishing the communication between the two devices, that is a sender device and a receiver other device. For establishing the communication now, the address the conversations can be used. So this is the functionality. With help of this functionality, one network address to the another network address can be converted. That is private network address to the public network address can be converted, and effective communication can be established with help of the NAT. Next, the functionality is a congestion controls. Generally, congestion, when will arise the congestion in a network? Suppose if the large area of the networks are large networks now, the load is excess. If the transmission load, the traffic is excess traffic is flowing over this network, the excess traffic is forwarding over the network. So generally in this case now, network the congestions will be arised. So excess load, while excess load is on a network, so it will be the congestions can be arised. It is managed using the algorithms like a leaky bucket algorithm. By using the leaky bucket algorithm, so these are the leaky bucket algorithm. The congestion can be controlled, and managing the congestion, avoiding the congestions over the network. So these leaky bucket now, which regulate the data flow, which leaky buckets are regulating the data flow at a constant rate, which is regulating the data flow at a constant rate. And token buckets also can be used for avoiding the congestions over the network. So these are the token buckets now, what it is doing now, which is transmitting the packets in the form of the tokens. Whatever the packets now, the packets can be transmitted in the form of the tokens now. By forwarding the packets in the form of the token, now the congestions can be controlled. That is the based on the packets now, the tokens will be available here. To ensuring these are the tokens now, generally which smooth data transmissions can be done with help of the other tokens. So that's why by using the token buckets and the leaky buckets, the congestion control can be done over the communication media. And encapsulations and decapsulations. Generally here network layer now, which is acting as a bridge. Encapsulation and decapsulation means network layer which is acting as the bridge between the transport layer and data link layer. The transport layer is above the network layer, and data link layer is below the data link layer. Here, if you want to transfer the data to the data link layer, from transport to data link layer, this network layer now, which is the converting the tokens into the data frames. That is, the tokens, whatever the tokens now we are transferring at the network layer, that will be encapsulated. The tokens will be the encapsulated. Whatever the data coming from the transport layer, that means data, generally the data coming from the transport layer in the form of the tokens. And also now which adds the important header part of the packets. Now whatever the data is the transferring here, for the data transparency now, the header will be the added, which consisting of the necessary informations. Like here now, which is consisting necessary information like the source IP address and the destination the IP address, source IP address and destination IP address. Based on the source IP address and destination IP address now, the effective, the reliable the communication can be done. Here after receiving the data packets on the destination side. So for understanding, for getting the original data, we are decapsulating can be done. We make them original data. For getting the original, whatever the data is transmitted at the sender, so it will be the encapsulated. Wrapping the data into a single unit. By wrapping the data into the single unit now, in the form of the encapsulations, the data can be transferred. So this is about the encapsulation and decapsulation. At the sender side, encapsulation operation can be performed. At the receiver side, at the destination side, decapsulation operation can be performed and getting the original data. Whatever the data is sent by the sender, that original data can be received at the receiver side. Protocols at the network layer. Here now, generally at the network layer now, we are using the different protocols. By using the different protocols now, the communication can be established, effective communication, reliable communication can be established between the two devices. So that the protocols are the IPv4 protocol or IPv6 protocol. That is a ICMP. ICMP means now, so it is a Internet Control Message Protocol. IPv4 is a version 4 protocol, Internet version 4. IPv6 is an enhancement of the IPv4. And ARP protocol. ARP the protocol and RARP protocol. ARP means here address resolution of the protocol and RARP protocol. So these the protocols can be utilized at a network layer for data transmission from the sender to the receiver. See IPv4 protocol. IPv4 means here Internet the protocol version 4. The Internet protocol version 4, it is a connectionless protocol. Here it is a connectionless the protocol that routes the data packets across the network. Across the networks now, the data packets can be routed. Generally, IPv4, which is using the 32-bit addressing system. That means now the size of the IPv4 is 2 to the power of 32. 2 to the power of 32 bits can be utilized for data other transmissions. This is the size of the IPv4. And IPv6, it is an enhancement of the IPv4. So it is an enhanced version of the IPv4. That means now IPv6. So which is using the 128 bits. 128 bit, the address space can be utilized in a IPv6. So that's why here generally the address in IPv4 now we can represent in a numerical form. The address in IPv6 now we can represent the address in a hexadecimal format. So, and improving the security and scalability features. Security features and the scalability features can be improved. Comparing with the IPv4, while if you transfer the data from one device to the another device now, if you utilize the IPv6 now, more the security can be provided. Next, ICMP protocol. Here is ICMP protocol, that is a Internet Control Message Protocol. So used for the diagnostics and error reporting messages. Diagnostic and error messaging report in a network communication. Generally here ARP. Next ARP protocol. ARP protocol now generally which is resolves the IP addresses to the MAC address. That is a medium access control. Medium access control means now every device which is identifying the IP address and to resolving to the MAC address, medium access control address within a local area network. So the manufacturer generally which is every other device has only one MAC address. Based on this, that means the MAC address now we can identify the uniqueness of the particular other device. The manufacturers know which they are at the time of the manufacturing now they will give the only one MAC address of per one device. So this is a resolution of the protocol. This can be resolved to the IP address to the MAC address within a local area network. and RARP protocol. RARP protocol means here reverse address resolution protocol. Reverse in a ARP mapping can be done IP address to the MAC address. In a reverse address resolution now, mapping can be done from MAC address to the IP address. The communication can be done by mapping this. Generally these RARP mechanism can be utilized in a diskless devices. If there is whatever the devices during the boot up here, if without the disk now, the booting process can be done. So in these diskless the devices now, these RARP protocols can be utilized. Here, real-time applications. Real-time applications generally here, voice over the IP. Voice over the IP is nothing but a mobile communication, which is allowing the voice communication. Mobile communication is the best example for voice over IP. This is a real-time application. In voice over IP also, these network layers can be utilized over the internet, over the internet or private IP network. With internet or so without the internet now, these Vivo IPs can be utilized with help of the network layering technology. And video conferencing also. Video conferencing, so it is enable the real-time videos and audios communication over the network. For example, Zoom meeting or Skype. So these are the video conferencing. In a video conferencing, now which is network layers can be utilized with help of by supporting of this network layer now. Zoom meeting can be conducted or Skype meeting can be conducted. The conferencing can be conducted. Video conferencings can be conducted here. The effective, the reliable the communication can be established. That is a real-time videos and audios communications can be established. Online gaming. So here next application is a online gaming. In online gaming now, the network by utilizing this the network layer now. So here multiple player games that requires the very low latency the communication between the physical between the players players in a online gaming in a real time now. With help of this now network layer, the communication can be established between the multiplayers. Industrial control systems, that is ICS and SCADA system. That means now, so generally these network layers are used in industries. So for real-time monitoring, now the industries, the employees work monitoring can be done with the help of the networking and control of the machineries and the system. Machineries and systems can be controlled. Manufacturing plants, power grids. So these are all the examples of the industrial control systems. Financial systems and stock marketing. Here is the next the real-time application of the network layer is a financial system. Financial banking, any bankings or stock markets. So these are all the best real-time applications for network layer. So these are the systems which is require the real-time data transfers. Stock marketing means now whatever the transactions, whatever the stocks are exchanging. So real time the exchangings which is showing to the end user by supporting of the network layer. Here for stock trading, banking system and other financial other operations. Telemedicines now remote the patient the monitoring and the doctor patient the communications in a real time. Here is the video consultations and remote other diagnostics are the examples of the telemedicines. Here for this the topic, the textbooks are the origin, data communication and networking, and another is the Tenenbaum. So by computer other networks. These two are the textbooks for these other network layer. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.